I have suffered from asthma ever since I was a baby. So it is safe to say I have witnessed the evolution of medication for asthma over a long period of time. At the very beginning, these used to be pills and capsules. Pills take time to travel to your target site along your bloodstream, and therefore it takes time for relief. Back then, I used to lie down and pray for sooner relief. Asthma costed me certain things in life throughout my childhood. Fun things like eating ice cream or taking part in sports and games. A couple of years later came dry powder inhalers. Better than pills, and I learned to live with side effects like drowsiness. But right now, we have aerosol inhalers. Much better, faster relief with no noticeable side effects. It feels great to be able to breathe again without effort and to eat all flavors of ice cream. Asthma is a common disease. It is not life-challenging in most cases. But even though today we live in a medically advanced world, there are many other conditions and diseases that challenge a normal, healthy life. I'm sure all of us sitting here at some point have wished for faster, better relief from medications and less side effects at some point in our lives. My point is, there's room for improvement regarding many medications we use in our day-to-day life. We can do better. And today, I'm here to tell you that there are ways to make drugs and delivery of drugs better using drug delivery systems. In my research, I tried to develop a protein nano vehicle to carry a package into the human body. The package in this case is turmeric. It is a very well-known antioxidant that is extracted from turmeric. It is a very well-known antioxidant, but also it is a dietary spice with many medicinal properties. The vehicle in this case is a protein that comes from corn. It is supposed to act like a cage and deliver the drug into the human body to the relevant exact location. But in our work, we observed that this delivery is not always successful. Sometimes the vehicle tend to clump together or fall apart before they reach the destination. And therefore, we had to look into ways to make this delivery right. And that's when we thought of a coating material. It is supposed to coat and wrap the vehicle and protect before falling apart too early. The coating material I use is tannic acid, another very well-known antioxidant that comes from plants. But why do we need vehicles to deliver drugs? And why do we bother to enhance the potential of these drugs? Now, here's a fun example. Imagine you lived a couple of 100 years ago, and there were no ships, boats, or ferries invented yet, and you somehow pick some extra apples this season that you want to send to a friend that lives in a village nearby a river. One can perhaps toss all the apples into the river and hope for the best. But some can get picked by your friend, but most will get eaten away, stolen, or wasted. But what if you built a raft instead? You can give raft the exact delivery address, and your apples will be delivered with no wastage and also in a timely fashion. This is exactly what I do. I build the raft, but more importantly, I look into ways to make the raft stronger so that it can withstand all possible hardships until its package is unloaded at the exact delivery address. My main focus in my research is tannic acid. This tannic acid is supposed to coat and wrap the protein nanoparticle and help it to get to its delivery location. In my work, I'm studying whether this improvement will help in enhancing the structure and function of the vehicle. This is how I see tannic acid in the lab. But all of you have met tannic acid too, in your cup of tea, coffee, chocolate, berries, and wine. Tannic acid is extracted and purified from plants and therefore safe for human consumption. But more importantly, I'm interested in studying how a digestive system reacts to these vehicles. Now, sometime after we eat our food comes to our stomach and the intestine to be welcomed by digestive enzymes. These enzymes break large protein into tiny bits to be able to be absorbed by the body easily. Same way, when our nanoparticles reach the intestine, The outer protein vehicle is broken down, releasing the drug. This plot shows the distribution of particle populations after 4 hours in a simulated digestive environment. We observed that the coated particles resist enzyme breakdown way better than the uncoated particles. This is great. This is what we want. We don't want our drug to be released right away. We prefer controlled release that leads to better absorption. We are closer to synthesizing better, improved protein nanoparticles. I work with protein nanoparticles, but there are many other kinds of nano-delivery drug systems. These are better, more stable, they are better absorbed by the tissues and show reduced degradation by enzymes in the body. Nano-delivery vehicles have already addressed many diseases and conditions. But not only medicine, vitamins, minerals, and supplements can be delivered by these systems. Scientists all over the world are working hard every day to discover and improve new nano-delivery systems, because we think we can deliver your drugs faster, better, and with minimal side effects. Nano-drug delivery systems are not just about making the delivery of drugs better. They are more about making people feel better. Thank you.